Hello everyone, welcome to our YouTube channel Incredible Max. In this video, we will solve a problem asked in CSIR NET February 2022 in part B. This problem belongs to the topic inner product. Let us go into the problem. Let n greater than 1 be a fixed natural integer. Which of the following is an inner product on the vector space of n by n real symmetric matrices? So this is a part B question, hence only one option will be correct. So there are four options. The four options we have to find which of the four is an inner product. So we already know the definition of inner product. So let us recall the definition of inner product. So let V be a vector space and x, y, z are any three vectors. So let x, y, z belongs to vector space V and some scalar belongs to f. Then this one x, y is equal to, so if we want to say this is an inner product, then x, y is equal to y, x, symmetric properties would be satisfied. And second one is additive property, so this would be equal to x, z plus y, z. And scalar multiple property k x, y, so this will be equal to k times x, y. Fourth one, x, x equal to 0 if and only if x equal to 0. So we will check the options one by one. So the first one is a, b is equal to trace of a into trace of b. So before that we will see some properties which are useful to solve this problem. So trace satisfies the linearity property. So that is trace of a plus b is equal to trace of a plus trace of b. And trace of k times a is equal to k times trace of a. And determinant property, so determinant is not a linear property, so determinant of a plus b is not equal to determinant of a plus determinant of b. And determinant of ab equal to determinant of ba if both ab and ba are defined. So now let us see the options one by one. So the first option says that, so the product a, b is equal to trace of a into trace of b is an inner product. This we have to check. So the first property, so we will check the properties one by one. So the first one, x, y is equal to trace of a into trace of b. So therefore, so since multiplication of two numbers, two real numbers is commutative, so therefore trace of a into trace of b will be equal to trace of b into trace of a. So therefore this one x, y equal to y, x. So the first is satisfied, and second one x plus y, z. So this will be equal to trace of a plus b into trace of c. So here we'll rewrite this one. So that is a plus b comma c. So this is equal to trace of a plus b into c. So this can be written as trace of AC plus trace of BC. Again this is product of A comma C plus of B comma C. So therefore the second property is satisfied, and third one is KA comma B is equal to, so this is defined as trace of KA into trace of B. So this is, take this, since trace satisfies the linearity property, trace of Ka equal to K times trace of A into trace of B. So therefore this is equal to K times inner part of A comma B. So therefore the third one is satisfied. So now we will check the fourth one. Fourth one is A comma A. We have to find A comma A. So A comma A, so this is defined as trace of A into trace of A. Suppose if we fix n equal to 2, then trace of A will be some of the elements in the leading elements in the 2 by 2 matrix. So A11 plus A22. So this is A11 plus A22. So this can be 0 whenever, so this is equal to 0 when A11 equal to minus A22 and this one A11 equal to minus A22. So that is A inner part of A comma A equal to 0 even when A is non-zero. So therefore, so option A is not an inner product. So option A is wrong, since it satisfies the first three and doesn't satisfy the fourth property. And B1, so we will see later, and C1, A comma B is equal to determinant of AB. So since determinant does not satisfy the linearity property, therefore this will not be an end product. And option D, so now we will see option B and option D. So option B says that A comma B is equal to trace of AB. So we will see the first property, inner part of A comma B will be equal to A comma B equal to, so this is defined as trace of AB, and since by the properties of trace of a matrix, two matrices, trace of AB is equal to trace of BA. So therefore this is equal to B comma A. So therefore the first property is satisfied. The second property, so A plus B comma C, so this is equal to trace of A plus B into C. So again this can be written as trace of AC plus BC. So trace of A plus B by property, trace of, this can be written as trace of AC plus trace of BC. So this will be equal to product of A comma C, and this is equal to product of B comma C. So therefore the second one is satisfied, and third one, so product of KA comma B, so this will be equal to, so this is defined as trace of KA into B by linearity properties of trace. So this can be written as k times trace of AB, so which is nothing but k times product of A comma B. So therefore the third is also satisfied, and the fourth one, A comma A. So if find A comma A, so this is trace of A square, trace of A into A, that is A square. So here we will fix n equal to 2, that order of the matrix as true. So if we take A as A11, A12, A22, and A, so this would also be A12, and this is A12. So now we will see why we have A12 here, because it is given that so our vector space consists of real symmetric matrices. So the real symmetric matrices, so definition, a matrix A is said to be a real symmetric matrix if A is equal to A transpose. So therefore, so these two symmetric entries are same. So what is A square? So A square is nothing but, so now we will calculate just only the diagonal entries. So A square is A11, A12, A12, A22 times here A11, A12, A12, A22. So we are going to calculate trace for this A square. So that it is enough to find the diagonal entries A11 square plus A12 square. So this you can calculate. So this 2 will be symmetric, and this entry will be A12 square plus A22 square. So we will from this one, so product of A comma A is defined as trace of A square. So trace of A square is A11 square plus A12 square. So this is 2 times, and this is A22 square. Rewrite plus 2 times A12 square plus A22 square. Suppose this equal to 0, so this implies sum of squares of each term is equal to 0, so each term will be equal to 0. So this implies A11 equal to 0, A12 equal to 0, and A22 equal to 0. That is, so when we substitute all these in A, so we will get A equal to 0. So this implies A should be a 0 matrix. Therefore, this implies all the conditions, all the properties are satisfied. So this implies C is an inner product. The function defined in C is an inner product. So C is the correct option. Sorry, B is the correct option, and C already we have proved it is false, and option D. So now we will see, check the option D. So it will be false. So this is A comma B is defined as trace of A plus trace of B. So the first property will be satisfied. So that is A comma B equal to trace of A plus trace of B, and this can be written as trace of A plus trace of B, and this will be same as trace of B plus trace of A. So this is product of B comma A. So the first is satisfied, and second one A plus B comma C. So this will be equal to trace of A plus B plus trace of C. So this can be written as trace of A plus trace of B plus trace of C. So definitely, so this will not be equal to trace of this will not be equal to product of A comma C plus product of B comma C. So therefore this is not an linear product, so D is false. So therefore the correct option is option B. So this is also wrong. So if you have any doubts or comment in this video, so kindly post your comment in the comment section. Thank you.